Good afternoon, everybody. Welcome. I appreciate you coming down to my session, especially because I heard we're competing with free beers down at the Tech Expo Hall, so I'm glad you could still make it for another round of technology. You're in the session called Monitoring and Managing the Network and Storage Infrastructure with Operations Manager 2012, and basically we're going to talk about System Center Operations Manager and how we can proactively monitor the fabric, in our case, network and storage. And my name is Maarten Goed. I'm a System Center MVP. I've been so for 6 years now. I'm involved daily with customers who need monitoring, who want to adopt System Center, and I'm about to share my practices, my best practices from the field. And if you want to follow me, I'm on Twitter as well, also tweeting on the TechEd hashtag today. So again, thank you. In this session, we have the following agenda. We're going to talk a bit about System Center Operations Manager 2012 itself and how we do 360 degrees of monitoring. We're going to talk about network monitoring extensively. We're going to do a deep dive on how that works behind the scenes and how things work. We're going to look at storage monitoring within Operations Manager, get around to how you could visualize that through dashboards, what's in the box, but also what you can do with vendors. And then talk a bit about capacity management to summarize how you could proactively look at trends, forecasts about storage growth, or even network usage. And then summarize the session. And we'll try and end on time so we have questions, so we can do questions at the end as well. But by means, if you want to make it interactive and you have a burning question, you can ask it during the session as well. So first, let's have a look at Operations Manager. Who's using Operations Manager today? Okay, fair show of hands. Who's using 2012? Okay, same hands almost. SP1? Almost same hands, so you're good, fine. So we're going to look into 2012, that's the good news. So you have the network monitoring, and we'll have a look on what you get out of the box and also the differences between generic, non-generic, etc. So any questions at the end are fine as well. So if you look at System Center 2012 Operations Manager, we actually try and bring you proactive monitoring for all these types of personas. So the infrastructure owner, for the service owner, but also for the CIO management level, getting them the right dashboards, reports, etc. And we try and do that bottom up. So we want to make sure we monitor all the infrastructure components, compute, network, storage, virtual networks, etc. We also want to monitor the application level, so we have an understanding of the health, the performance of the applications, and we want to do that for both the Windows world as well as the cross-platform world, so Linux, Unix, Java, Oracle, etc. And then one of the key things with Operations Manager is to also be able to measure the end-user experience, the synthetic transactions, where we measure how an app or a user would access that service and see whether or not it's healthy. We want to bring that together so that when an end-user perspective will fail, we can actually have a look in the infrastructure on what the component is that's failing, that's responsible for delivering that service. So you get a short time to resolution and be assisted and guided into getting the resolution. I want to do that from a consistent user experience. We want to give you a UI where you can both have a look at the infrastructure level, the application level, the end-user experiences, but also have a look at reports, dashboards, etc. And I'll show you in the demo. And then we also want to provide that same experience through methods you might already have, portals like SharePoint, the web console, and other stuff. So we want to provide you this consistent user experience. With all that, we want to provide you a 360 degrees, so both the end-user perspective, the infrastructure, tying it all together, and showing you proactive monitoring. Now, these synthetic transactions come out of the box. We have things like URL monitoring. We can have a look at TCP ports, at processes, etc., both for the Windows world as well as the non-Windows world. We have the DevOps integration, so whenever we signal that there's an application failure with the new integration to TFS, but also the application performance monitoring, we can have a deep dive look into .NET and raise a ticket or a bug in the corresponding TFS project, so really close the loop when it comes to both the dev and the ops world. We have a dashboard framework, which I'll be showing you at the end, how to tie things together, where you can visualize these points to your end user, the management level, etc. And then, something happened. And then, of course, the management packs that really light up the monitoring, right? You get these management packs out of the box. You can download management packs from the Microsoft website and plug in, for instance, a SharePoint management pack or an Exchange management pack. You can create your own management packs if you want to create monitoring for an app that we don't have out of the box. And there's also third-party vendor management packs, like known management packs such as Veeam, who does the VMware monitoring, or OpsLogix, for instance, the Oracle monitoring. And then one of the new things you saw if you followed the news recently is cloud monitoring. There's an Amazon management pack, there's an Azure management pack, so we can actually see instances for both the infrastructure as a service, we can see the platform as a service. Again, so we get this 360 degrees insight into your environment and show them in as part of a dashboard and show you health and performance of those key components. So that's so we're all on the same page. We're trying to provide you with comprehensive proactive monitoring. And of course, one of the key things we want to show you in this session is how to go about with your network monitoring and your storage monitoring with Operations Manager. So first have a look at the network monitoring piece. Because since 2012, it's in the box, right? You get it as part of your product install. It's in administration. You can actually hit up the Discovery Wizard and add network devices. And those network devices give you, we do discovery, so we find your devices. We do monitoring. We do comprehensive monitoring for the models we know. We provide you with out-of-the-box dashboards, which I'll show, and also out-of-the-box reports. And then we do server-to-network dependency discovery. So we find a network device, we find a port on that network device. On the other hand, you might be monitoring a Windows server, maybe on a virtualization stack. We find the corresponding logic, like MAC addresses or IP addresses, and then stitch them together, which I'll talk about in a second. We have multi-vendor support, so with SP1, we support over 80 vendors, over 2,000 devices. There's actually a list published on Microsoft.com for the devices we support, and I'll talk in a second about how should we go about if it's not supported or if we classify it as generic and what do we get then. And we have multi-protocol support, right? Not sure who uses SNMP v1 anymore, but you typically see some data center sensors like humidity or fire sensors that might be talking v1. We support that carrying forward. v2, of course, but also v3 if you want to be more secure, people and enterprises using v3. And we can do that over IPv4, which is logical, I guess, but also over IPv6. It will require your Windows, your management server, your Operations Manager management server to be on a Windows Server 2012 box. So we actually can do IPv6 natively with the product. Now, what do we support? We support all types of devices, and by no means is this a full list, but we do support things like bridges, load balancers, switches, hosts, firewalls, routers, hubs, and more importantly, we support with SP1 virtual devices, meaning the virtual switches, the virtual ports you get with Hyper-V network virtualization, which is a key aspect you might want to monitor and see performance of your network there as well. We support those out of the box, and it all starts with, I guess, discovery, finding the devices, adding the devices so that we can actually do a discovery of what the device is, what types of component it has, what we should monitor when it's a problem, and show you alerting when we actually find problems. So what is discovered when I add a device? What we actually will discover is the device itself, of course, with all its components. We'll actually discover the connectivity. So we will go about and find server-to-switch connectivity, which we talked about, the port stitching. Also switch-to-switch connectivity, switch-to-router, etc. So we'll find you your other devices, and I'll talk about in a second about the caveats there, but we'll try and build you the network map. We find VLAN membership for those devices that actually are configured as VLANs. For the Cisco devices, we actually support the HSRP groups, which are in essence the high availability groups you define over multiple network devices. We'll find them, we'll actually find the devices, and we'll group them as part of the HSRP discovery. We do the port switching and then the key components like ports, interfaces, processors, memories, fans, what have you on a network device. Now, if you want to add a network device, there are actually two ways of going about. There's what we call an explicit discovery, So you know the IP address, you have a list, you know all the read strings for SNMP, and you just want to add that full list and be able to discover them, and you're good. But there's another option called recursive discovery, where you might not know the network topology just yet. We do require you to add a few seed devices, so maybe a core backend switch, and then based on that, we'll actually go into the ARP and IP tables and see with what other devices the switch is communicating, and then go to that device, start discovering it, etc. It will require you to set upfront a list of the possible SNMP read strings, so we can actually reach out to the other device, apply that read string, see if we can get in, discover it, read the ARP and IP table, go to the next one, and I think you can carry that forward from there, so it will actually start mapping your network. It works quite nicely, actually, but it depends on the communication between the switches and us reading the ARP and IP table. So we don't use things like the Cisco Discovery Protocol or such, which are common questions I get. So then we have access to the device, right? We can do an SNMP walk. We get all these information back, and then based on that first assessment, we have 3 discovery stages. So we do the initial probing. We reach out to the device, see if we can reach it. We have the processing phase, and then after that, we have the post-processing phase. And I'll go into detail on these phases so you have a clear understanding of what we're doing while we're adding these devices and while you're waiting for them to show up in the console when you're adding them through the wizard. So the initial probing phase is where we actually will do an ICMP ping and or an SNMP get to that system. And I say and or because you might have disabled ICMP and don't want us to ping the device. And within the discovery, you can actually set it to just use only SNMP. And we actually find that system, do get location, get sysinfo, and understand that we're talking to the right device. The processing will say we'll get the components, IP addresses, the VLAN memberships, resources, IP networks, net masks, etc., etc. And we build this initial topology. And then post-processing, we actually start understanding that we have a switch with a certain port, with a certain MAC address. We see on the other hand our Windows server with that MAC address, and we start doing these things like port stitching and such. So after you see the device in the console, it might take up to a minute or so to actually see the port stitching happen and the map to build out even further. So it's a post-processing stage. Now for in the initial probing phase, we actually will use SNMP v2 by default. So if you just leave the wizard as is, it will do SNMP v2. If you wanted to talk v1 or you wanted to talk v3, you might want to go ahead and set that explicitly in the discovery wizard. Then if you don't change anything, we will first do ICMP ping to see is the device reachable, and then do an SNMP get if that's successful. If there's no response on either, so whether it's ICMP ping or SNMP get, we'll actually set the device to pending for you to understand that we've tried, we've failed, but you want to go ahead and configure something, right-click, retry, so it actually will discover. Now, v2 doesn't work, so we do an ICMP ping, that's successful. We do an SNMP get, v2 fails. We will try v1, and if that's successful, we will actually add it. And you can see a screenshot from a network capture I did a while back on those things happening on the network level. So if you look at the SNMP request, you have some common variables under a certain namespace called, well, you see the number there, which will get. Those are the things like the version of the SNMP, the community string, the sys description, the object ID, the contact, the sys name, and the location will get initially to get the basic information from the switch or the network device. And we need to get all 4 or 5. If not, it will actually go again into pending management for you to fix that and make sure that we can retry it after you've set the configuration. And this is an example, for instance, in my lab, a Cisco Catalyst 4506, and you can see what's being returned, for instance, with the OID location, it's a certain building number, certain contact name, etc., etc. So these are the names and the bits of information that actually will be part of the device information, what you see in Operations Manager. If you go into one of the views, see the properties of the device, this will show up as part of it. So make sure that's well configured if you want to use it for grouping or notifying or whatever you think that's necessary. So with the network discovery itself, we did the initial probing. We're successful in doing the SNMP get. We want to get further information. We will do a full SNMP walk to get information from the device. We will actually check the OID2 type in a management server configuration file called config files under the path you can see at the first bullet to see if we have an understanding of the switch. This technology was actually acquired by Microsoft or licensed by Microsoft from EMC Smarts. So we use their basic understanding of the network world. All the device monitoring we need to apply is based on these files. And with every update, so SP1, roll up this and that, you actually will get updates to those files so you can do more extensive network monitoring going forward. Now, if it matches, it will actually be a fully discovered device and we'll get details like we just talked about the IP addresses, the physical parts, the neighboring devices, etc. Then we'll identify the device type, whether it's a router, a switch, a hub, a bridge, but also the vendor and the model. And then also what probes to use. So we need to know for this Cisco model, I might need to look at some core component and apply this monitor, while for an HP switch it might be something else. So it actually starts understanding which monitors, rules we will be applying from Operations Manager. And then we set a level of certification, whether it's a certified device, we have an understanding of it, we can do deep monitoring, or a generic device. And that's a terminology that's fading away a bit. If you look pre-SP1, so 2012 RTM, you went into the administration page, you went into network devices, there's a column saying whether it's generic or certified. That column is gone with SP1 because there's no such thing as certified. There's just a thing that we understand the device and can do more in-depth monitoring. But there's also for you a way to extend this. So if it's a model we don't know about, you might be able, or you might want to add your own rules, monitors to complement. And there's actually third-party vendors today that will allow you to do so without any authoring knowledge. For instance, there's a site called mib2mp.com. They process your MIB file, and they give you back a management pack which you can load in Operations Manager, and you get more or less the certified state of monitoring a network device. So there's a thin line between us having an understanding out of the box and you complementing it either through a third party. And the MIB2MP solution is actually quite nice, so you don't have to know all this authoring stuff. Then in the network discovery, we have the post-processing phase. The device is added in the console. You can have a look at it, right-click it, diagram view, see what we're monitoring. And then behind the scenes, the management server that's responsible will actually create layer 2 and layer 3 connectivity in the topology. It will do the port stitching based on the understanding we have of the servers we're monitoring, do the port stitching, draw the lines, start building your map even more. Remove MAC access points that do not belong to devices in the topology. Create network connections to represent the wide area network and other connections based on the discovery protocol. So it's a post-processing phase where we apply all this logic, so we build a bigger map of things to show you how the network is actually configured. Now, one of the things that might be helpful is this slide, and you can download this from Channel 9 afterwards as well, is once you're adding devices, it might not be clear to you why things are ending up in pending management or why it didn't show up as a port stitch to the server you're connected to. These are the discovery events to look for on the management server. The management server that's actually doing the network discovery for you for that device, because I'll talk in a second about resource pools, but this single management server in his Operations Manager event log, these are the events you want to follow. So things like full discovery started, topology cleared successfully, proceeding, etc. So you can see whether we're in the initial probing, processing phase, post-processing phase. And then if you look at the event details, it will give you an understanding of why it wouldn't be successful at that event. Now, you don't need to go into the event log to get these events and remember, oh, this was like 12.002. There's a view called Network Discovery Progress Event. It's under the Operations Manager view folder, which actually will only show these. And then so once you hit off the discovery, you can just set it to that view, start seeing how it adds the network devices. So that's a good view to have when you're troubleshooting or adding devices. So that means we got the devices in, right? Then we need to go to the monitoring stage where we actually look at the devices and the health. We support resource pools for high availability monitoring. Now, of course, this means that all these management servers need to be able to talk to these devices, right? Because it's just network connectivity we're doing from the management server to that device. So if you have multiple management servers in a resource pool dedicated or using for network monitoring, make sure they all are able to connect to these network devices, plus the read strings you're configuring in the management server, in Operations Manager, distribute those run as accounts to all these management servers, otherwise it won't have an understanding of how to connect. So the resource pool is nice because we can do high availability monitoring. One management server might fail, then the second would take over, and we can just go about network. So the network devices themselves are discovered as an instance of the system.networkmanagement.node, and of course there are more specialized classes after that to represent components such as CPU, memory, ports, etc. But network devices are discovered as this base class. If you want to go ahead and use the Service Manager integration so that your network auto-populates in your CMDB, you want to add this to the whitelist of the Operations Manager connector, so those actually flow into Service Manager, create a view to show your network devices. Actually, you have a blog about that on how to do so step by step. Now, for the monitoring piece, only certain ports will be monitored by default. If you look at a device discovered, you might right-click, diagram view, look at the ports and say, hey, most of the ports are maybe in an unmonitored state. They show up as a blank, round, green thing. The reason being is that we will only monitor if the ports are connected to something, right? To either a server or another network device, so network data actually flows. So there's also reason to start monitoring that port. If it's administratively shut down or it's not connected to anything, we will not enable that monitor by default because it will likely just cause noise. And that's not something you want to add to Operations Manager. Now, there is a way to enable and override that, of course. If you want to go ahead and still monitor that port for some reason, just right-click and set it with a task to enable monitoring, or set an override so that you get it forced for a certain group. And then there's a way to do rediscovery. If you use the wizard in Operations Manager, walk through the discovery. At the end, it'll say, do you want to schedule this discovery, do it every night or whatever, right? Actually, at the rediscovery, we will see whether or not a port is now connected and then enable the monitoring for you. So if you want to schedule it every night, you'll get monitoring at least after 24 hours automatically. So that's a good thing to think about. Then for all devices, so not the specialized devices, but all devices, even if it's like a data center sensor, these are the monitors and rules you get out of the box, and whether or not they're enabled by default. Oh, there's a question.
On the previous slide, the last line there made it sound like it will only be monitoring ports that are connected to something you're managing, like, for example, in Operations Manager, I don't want to monitor all the ports the clients are connected to. So does that last line mean it's only going to be managing ports that are, like, say, servers that are in SCOM?
Yeah, I'll summarize the question also for the recording. So will the port monitoring not be enabled if the device on the other end isn't added to Operations Manager? The answer is yes, it will not be enabled because we don't have an understanding of the device. If you still want to go ahead and monitor those, you could still override them or use the task to make sure that you still are looking at the port. So that would be a feasible scenario where you create your own overrides, I guess. But yes, that's the way it would work out of the box. Yeah. So the device added, these are the monitors and rules you get out of the box. ICMP ping, so we ping the device on a certain schedule, see if it's still available, raise an alert if it's not. SNMP ping, or SNMP get, if you will, see if we can still get sys location, so we are able to still access port 161. And then for the rules, you have things like response time, so there's a nice performance chart on response time on ICMP level. Things like trap received. Some of these devices actually support that they trap you a certain alert if a device does a warm start, so you can actually have a look what happened, etc., etc. So these are the monitors and rules you get for all devices. Now on the top right, you now see a block called certify the devices. So this means we have an understanding of the device, it matched against our OID config file, we can do deep monitoring. Then what do you get? We get for the port and interface class up and down, so whether or not a port is operationally up and administrative status. Volumes, so like inbound, outbound traffic we monitor, we capture, you can do your performance graphs. Percentage utilization, the discards, the drops, the errors, so that's for ports and interfaces. Processor utilization, and then for Cisco models, we do the in-depth memory counters, and then for all other models, we actually do free memory, collect those for you to understand. We look at connection health, so whether or not a connection is up, and show you VLAN health, all the states of the switches that are part of this VLAN group, and the same goes for HSRP, Cisco-based high availability, and show you health states of the individual endpoints.
What about like an ASA firewall that's running a BGP protocol where they're actually IP'd identically, and until the failover, you actually not connect to the other one without using a are those things that you can monitor from Ops Manager as well?
So if I summarize correctly, I think you're asking, like, can we monitor on a lower level, like on a BGP level, to see if there's what the health state is of certain devices? Actually, no. So we go in through SNMP. So it's based on what we get back from SNMP. So if there's a device status that will show us that, we don't go lower than the IP level. We'll actually be able to, we'll rely on SNMP and the device information to get your information back. And for BGP, it would also mean that likely you'd need to create your own rule or monitor if it's not out of the box, if it's not an event we know about. So that would be a more advanced scenario, I guess. Yeah, sure. Now, if you look at some of these certified devices and their monitors and rules, these would be typically monitors and rules you'd get. So things like free memory on Cisco devices, giving you an alert if it's dropping below a certain level. Things like memory pool fragmentation, processor utilization, give you alerts on that. And then rules like the free memory it's collecting, the processor utilization we're collecting, again, for reporting purposes and performance graphs you might want to do. Now, these monitors, you can have a look at the properties, see which OIDs we're referencing, have a look at the parameters like the interval, etc., and apply overrides if needed. If you want to go ahead and change them out of the box, I think we do like a 2-minute interval, which is actually quite okay for most environments. So we talked already a bit about what's in SP1. The new thing in SP1 is that we added a lot of new network devices. Again, we rely on EMC smarts to bring them in. We will ship them then in the box, update the file so you get this updated network monitoring. Again, there's a link where you can have a look at the network device list that we support today as what we would call certified devices. We now do the virtual network monitoring, and we rely on the connection to Virtual Machine Manager, because Virtual Machine Manager 2012 SP1 will supports Hyper-V 2012, supports the network virtualization, and we get the information of that virtual network through the VMM connector to OM, and I'll show you in the demo. And then we have some new dashboards, of course, targeted towards this virtual network. So you see the virtual vicinity dashboard, the virtual node dashboard. Again, I'll show you in a second. Now, I wanted to do a live demo, and unfortunately, I couldn't connect back to my Amsterdam setup. So what I did is I pre-recorded the demos, so I can at least show you the full demo instead of a not too great experience through RDP at the moment. So bear with me while I start up the video. If you're in the back, you might want to sit in the front so you can see everything, because I can't use Zoom it to actually show you. So I'm sorry about that, but at least you can see the full experience. Switching to my PC. 2. Sorry about that. Just failed on me. It's now an 8.
Yeah.
Okay. Sorry, guys. At least we're here, right? There we go, the network monitoring. And I'll narrate a bit. So the first thing in this demo is that we're going into the Virtual Machine Manager console. This is VMM 2012 SP1. We go into settings, so we actually configure the connection between VMM and Operations Manager, which we'll use later on to do the virtual network monitoring. Currently, the state is okay in my environment. I'm connecting back to one of my management servers. I've got the connection enabled for both Pro, maintenance mode, plus the initial connection. And the management packs actually get imported as part of this process when you're setting it up, so that we flow the information from VMM to Operations Manager. Now, there's a way to test if the connection is working and also to force the first information to go over to OM. And it's a PowerShell command called write SC Ops Manager connection. What I'll do is I'll take the VMM information, talk to the Ops Manager SDK, do an initial push of the configuration, and then carry it forward from there. So if I hit write SC Ops Manager connection in my environment, it should actually say it's enabled, true, connection status okay, connecting to the PCI SCOM 2 management server. In my environment, I actually have 2 of these management servers. Now, this is the Operations Manager console. We're in the monitoring page, and you guys probably recognize this, right? And then with the integration, you get the Virtual Machine Manager view folder, and there's a subfolder called Managed Resources. And under that, there's multiple views, of course, application, clouds, virtual machines, what have you. But there's also host health, and these are the Hyper-V hosts I'm running in my environment with their health states. And if I click on one of them, one being the PCI ST2, it's actually monitoring. As you can see, it shows you host memory utilization has actually exceeded our threshold. Now, on the right-hand side, you actually see a couple of links to a certain number of views, one being the virtual node dashboard. And if we go to the vicinity dashboard, it will give you the vicinity view targeted from this Hyper-V host. So we see the Hyper-V host is connected to a virtual switch called Converged Net Switch in my environment. And this is the one we want to have a look at. So from there, we will actually click the virtual node dashboard. And now we're looking from the perspective of this virtual switch on this host. We get the instance details. We get the vicinity view in a few seconds. It will actually show us the virtual machines that are connected, the physical switch that's connected, of course, and we can zoom in and have an understanding of the virtual machines, the virtual network adapters. And if we scroll down, we actually see things like the health of interfaces on this node, see things like sent bits, received bits, and all these kinds of information. So this is something you get out of the box with SP1, the connection between VMM and OM in these new views called the virtual node dashboard and the virtual vicinity dashboard. And from here, we can actually, again, dive into performance views, maybe have a look at the Health Explorer, and in this case, see the number of bytes that we received on this virtual network adapter for this virtual machine. Okay, if we have a look at the physical networking, what we'll actually do is we'll go to the administration page, and we'll have a look at the network device discovery. And you'll find that under network management, and you see that I have 2 discovery rules already set up. One for my HP switches and one for all the other network equipment. And you can have a look at the properties. And what you actually see is that we gave it a name. We have a certain management server that we're using. We can have a resource pool that's applied, so it can do a failover to another management server. And then you can actually easily create those resource pools, of course, from the wizard here in the administration pane. For instance, a network, you choose your pool members, and you should be good. Okay, and then the next step will be the discovery method. And we talked about explicit, which is a list of IP addresses of SNMP read strings, or the recursive discovery, where we actually need 1 or 2 seed devices, and then go discovering from there. Now, I've already set up the run as accounts, but you could easily create them from here. Again, just type in a community string, and at the end, don't forget to distribute those run as accounts to the relevant management server so they can actually use them in the discovery phase. And then next, we're using explicit discovery, so I actually set up a list of all the devices I want to add. And here you see whether or not you were using SNMP only, ICMP and SNMP, using V1, V2, V3, the port number, the selected default account for the community string, and all this you want to add. Now, this is also available through PowerShell if you want to automate things even further. And there are advanced discovery settings on the number of retry attempts, the timeout seconds, etc. Then we talked about the scheduling of the discovery. So there's an option at the end saying run the discovery manually, or you can schedule it for a certain time, for a certain day, and then it will do rediscovery if you want it to go back and change things if we see ports connected. And then if you look at network devices, you actually see the ones that were discovered in my environment. So HP switch in this case, and if you look at location, model, description, etc., those are the things we got from the initial probing in the initial SNMP get. If we go to the monitoring page, there's a section called network monitoring with a view called network devices. It's actually where the devices will show up. And we can have a look at the HP switch that we added. So you can right click and have an understanding, for instance, of the diagram view. See what components we found, whether or not the components are being monitored. Yep. And this is where we see both the not monitored and the healthy ones. Again, these are the 5 ports in my environment that I really have connections to other devices. So those end up as being monitored by default. And there's a large number of not monitored because actually physically there are no cables in those ports. But again, if you click on them on the right-hand side, you can just click Enable Monitoring, set overrides, make sure if you still want to monitor them that they get to be monitored. Of course, from there we can have a look at the Health Explorer, see what monitors that are applied to this device, things like the network device responsiveness, performance monitors. Can have a look at the port monitors and also see what's monitored there. So things like interfaces flapping, interface status, performance, like high error percentage, high queue drop, etc. So those are the things you just get out of the box. Of course, we also have performance views. So from here, we could actually select the port, do things like open performance view, and then have a look at this port. And for instance, the inbound and outbound traffic, have an understanding of the utilization of this one. And then you see a fair amount of data occurring. And then you can set the time range, of course, to view it through this console or use reporting to go even back further. Now, even for the physical devices, we have a dashboard called Network Node Dashboard, which tries to give you an at-a-glance view of this network device, right? So you see the vicinity view, we see the availability view, instance details, average response time, all these things to give you an at-a-glance view. And we actually see that HP switch 1 is connected to HP switch 2. It found out so through the ARP and IP table. And if you right-click the line in between them, you actually can have an understanding of which ports are connected. So in this case, port 21 on switch 1 is connected to port 21 on switch 2. That's actually how physically the cables are connected between the two. So those are the line properties. You can have a look at the health of the interfaces, the 5 that we are actually monitoring, etc., etc. So that's an easy way to get an understanding of your network device. And from there, you could actually also start a targeted report and look at this port, how it's been doing in the past month, past year, add an object. There we go. Select a certain port number, port 21. And then run a report against it from this month, first day, until today. That works. Okay, good. Well, that's what I wanted to show you initially from the network monitoring demo. Again, sorry for it being a recording, but at least you got an understanding of how it would work, how you add the devices, how monitoring shows up, the dashboard you get out of the box, and then get a bit of monitoring. So the question is, if we do the recursive discovery, will we find devices behind the VPN line? We just rely on us being able to access it through a logical connection. So if the management server can access it on IPv4, IPv6 over that connection, we can do an SNMP ping or an SNMP get. Yes, it would work. But I guess if you want to monitor it, the line should stay up indefinitely for us to reach that device. But yes, if we can logically reach it, it would be no problem to do so over an IP VPN. Yeah. Okay, one of the questions I get a lot is the licensing, because it used to be different in 2007, and we now have the System Center license, and then you get into the story of, but do I need to pay for a license for my network device? In general, I'd like to say no, and you see most of the columns are no. If it's devices that live in OSI levels like 1 to 4, if you will, you'll not need to pay for a license. Now, if it has something more as a function on top of this network device, for instance, a network attached storage device, which actually also hosts storage and gives you ability to place storage, or it's a proxy server or a firewall, you actually do need a license because it's not considered to be just a network device, but a more intelligent function to Microsoft. So this is about the guidance you're going to get on the licensing piece. And I'm by no means a licensing expert, but just want to get the word out. So next up, storage monitoring. How do we go about storage monitoring? Well, there are two options, in my opinion. If you have your storage integrated into VMM, which today has options like SMIS, we can connect with the SMB3 file shares. We can talk to all these kinds of storage. We'll get that information from VMM through the same connector into OM, and I'll show you in a second. So that's a good way if you already have the connection into VMM or want to get the connection to VMM. And of course, there are storage management packs. We don't have a generic function like network monitoring today, but we do have a lot of vendors that supply storage management packs, and there are even third-party vendor management packs on storage monitoring, which you could also utilize. Now, if you look at the storage monitoring, it's based on the OM VMM connection, like we just said, so we'll get all these device information back from VMM. But we will also be able to alert on thin provisioning. If it has an understanding of the LANs that are coupled, and it's actually based on thin provisioning, we'll give you alerts when we reach the maximum capacity, and we'll give you dashboards on viewing historical capacity and identifying which VMs are affected by that capacity exhaustion. Now, if you look at the storage management packs, I guess storage monitoring is about the device itself, the file system on top of that, etc. So you could, of course, use the file server management pack today, look at Windows Server 2012, storage paces, the volumes themselves, the disks, all the things you get from the file server management pack and the base OS management pack. Now, if you look at vendors like HP, IBM, Dell, etc., they supply, in general, a storage management pack, and there are third parties like Uplogix that build management packs, for instance, for NetApp, etc. And again, there is a chance that you have authoring experience and will be able to author your own, but I guess you'd first look at the third-party options there. And we'll switch back to my laptop to give you a demo of the NetApp simulator I had in my lab and give you an understanding of how to monitor this. First, we'll go back to VMM. Again, on the fabric side of things, there's a section called storage, which shows you the providers, the arrays, the file servers, etc. These are the providers I have in my environment. So I'm talking, in this case, to a PCI NetApp provider. I can have a look at the arrays, and I actually see a NetApp array that's available to us. And because it's a simulator, it only has so much storage. But it's responsive. It has 3 pools, aggregate 0 to 2. And if you look at the pools, I've actually classified those pools to be bronze, silver, and gold. And those are the LANs that are actually available through iSCSI to VMM, and we're talking with the provider to get information on those storage pools. So this is typically how you'd see it in VMM and use it for your VM provisioning and what have you not. And you'd see the provisioning type, whether or not it's fixed or thin provisioned, based on the information we get back from the provider. And like we said, we could also now connect to SMB3 file shares and have an understanding of the capacity there. Now, if we go back to the Operations Manager console, and we go to the monitoring pane again, and we go back to the Virtual Machine Manager view, Manage Resources, then you actually see a view called Storage Pool Health. There it is. And in the storage pool health, we actually see the storage pools that we define in VMM, so the aggregate 0 to 2, and also the iSCSI target that we got. And then you get the basic information such as the total capacity, capacity used, the ID, the classification, in this case it's silver storage. And we can open up the Health Explorer, and in this case it's warning us about capacity because apparently we're exceeding the capacity threshold. If you look at the details, the threshold is at 85 and it's actually utilized at 89, so that's why it's flipping to warning. We can also right-click and go to Performance View if you want to have a clear understanding of capacity growth or used capacity. You can have a look and do a performance view from that as well. So those are the things we get, I guess, through the VMM connection and through the fact that VMM was configured to talk to this storage. Now, if we close this view and we go into the regular management packs, I've already imported the file server and base OS management pack and what have you. And we're still going back to the alert showing you that we breached thresholds. Well, you guys believe that we're good. Okay. So I've got these all other management packs imported, and so if you look at the new management pack, there's a file and iSCSI services management pack. And if you look at the iSCSI targets, we actually find the iSCSI targets running on these machines that supply us these LUNs. So we can actually have an understanding whether or not the target is healthy, still functioning. So those would be one of the key pieces you'd also want to do for monitoring, so you can show them on your dashboard later on. There we go. iSCSI target state health. And it's running, and we can actually have tasks from here to query the iSCSI target, start the iSCSI target, etc. Then if you go into the Windows Server view, which is the base OS management pack, there's a view called Disk Health. And we can have a look, for instance, at the disks, like the drives that are physically available on the server. We can also have a look at the cluster shared volumes, etc. So we can do storage monitoring from there, have an understanding at least on the disk, whether or not the volume is corrupt, whether it's working, if it's filling up quickly, etc. So there's monitoring applied, which will give you alerts and performance views based on those, like the logical disk free space 1 for Windows Server 2012. There we go. And then there's another view, current disk queue length. If you go to the other view, there's one called disk capacity, which will actually try and give you an understanding at a glance of the free space that's still available on those volumes and give you some performance views out of the box. Now again, in my environment, I also have a NetApp device emulator running. I don't have a NetApp physical device. And if you want to try that out yourself, it's available on the NetApp site. And what I've done, I've set it up on a Linux box. And to show you that it's not smoke and mirrors, I'm remoting into that box. And the Linux version itself is also monitored in our environment, so we know the health there. We SSH into SUSE 01, and then show you that we're running runsim, which is the command that is the NetApp emulator. And then if we go into the emulator, attach back to that screen, we can actually have a login to the NetApp simulator. This process is here. Login with root, get a password. Then we can have a understanding on the aggregate, so the raw volumes on these devices. Aggregate status, so the 3 that we saw in VMM, aggregate 0, aggregate 1, aggregate 2. And we can have a look, for instance, at volume status. And these are the volumes vol 1, 2, and 2 that are based on these aggregates. So we have a NetApp emulator, we have some raw storage, volumes based on that, and those are the volumes we want to publish to our clients. And we can actually have a look in the NetApp admin page, in the filer view, to also have a look at the disks that are behind those. Those are virtual disks, I guess, because it's an emulator, but those are the things you would normally see, I guess, from your physical storage. Volumes, aggregates, and then the storage disks associated with those. Now, how would you go about monitoring these, specifically for NetApp, but for most of these storage vendors it's the same? You actually add this device through SNMP, and it won't be picked up by the extensive monitoring by OM because it won't recognize it as a network device, but you can add it through the SNMP wizard like we just saw for the network devices, and then import the NetApp management pack, and that will actually do that extensibility, see about the OIDs and all the information we get through SNMP, and start mapping out all these items such as the aggregates and the volumes. So if you go to, for instance, the controllers page, it found that we have one controller, one logical unit from NetApp with a certain IP address, certain usage, certain name, etc. We can have a look at the aggregates, which will show up as single instances. So aggregate 0, 1, and 2 gives back the RAID types, the disk count that are associated, and things like the volumes. Have a look at volume 0, 1, 2, etc. And then we can also go to the diagram view and have an understanding of the total device. And so you can drill down into all the storage components based on these. And again, we rely on SNMP and their management pack to surface this all in Operations Manager. And based on the green check marks, you actually see that there's a lot of monitors associated that will give you information if things are failing. And if you look at the performance views, actually NetApp does push quite a lot of information out, like processor utilization, I/O, resource utilization, reads, writes, throughput, latency, and what have you, all the protocol information. So this is a virtual device. I'm not doing too much on it, not a lot of information I get, but normally in your environment you would get more information, of course. Now, NetApp also delivers a few reports. So if you want to have an understanding long-term on the storage efficiency or things like availability reports, you could do so through the generic reports, but they have some canned reports you can just use and give you a volume storage efficiency report, for instance. So that's good. So that's a quick overview of how you would do storage monitoring, either through the integration with VMM or a third-party management pack. Now we have all these components in there. We have network devices, storage devices, OSs, our apps, and you want to bring it together to give you an at-a-glance information of your service end-to-end. And for that, you'd need dashboards, right, to give you the visual representation of that information. Now, in my humble opinion, I think there are three ways to get that right. Either through the Operations Manager dashboard framework, which we have out of the box. You could have a look at Visio and SharePoint. As of SharePoint 2010, we have Visio services, and there's a Visio add-in you can download from Microsoft, which connects to OM and allows you to create Visio diagrams and publish them to SharePoint. Now, if you're already on SharePoint, that's a viable option. And there's a third-party vendor, which is actually at the Tech Expo, called Vision, and they have live maps, and I'll show you the difference and what you can achieve. So out of the box with this monitoring, you get the dashboard framework items like network summary, network node, network interface, vicinity, the things you saw in the demo, which will give you an understanding of your environment. Things like reports, memory utilization, processor, port traffic, etc., etc. And then the network summary screens, the node, vicinity. Well, I think you saw them just in my demo, right? Now with Visio and SharePoint, like I said, what you actually do is you take a Visio diagram, you create it yourself, you hook it up to Operations Manager, drag the states on top of that, publish it into SharePoint, and anybody access to that team site, to that page, can access that information, and you can build your management IT portal, if you will, and also have these graphical representation, and there are a lot of blogs out there that will guide you to get this done. Now, if you want to have it more interactive, you might want to have a look at live maps. It allows you to do drill downs where you create your views on data centers, on countries, on floor plans, and zoom all the way into racks, networking, etc. And that's actually the stuff I quickly wanted to show you guys on how to achieve some fancy network monitoring. So what we did is I already pre-created the live maps through the authoring console, published them in a folder called Private Cloud Infrastructure Monitoring. And in my case, I want to show the HP networking equipment. So I created a view called HP, like a top dashboard on the blade system, front, back, and also something on networking. So you actually drag these blades on top of there, drag the health states, and get like a dashboard on your fabric, on the compute side of things. This being the front physically of my blade system, but also the back where we have the things like the fans, the interconnects, the virtual connects, and get the information through the HP management pack, but build them as part of a live map to give you this drill down into your environment. But if you look at the networking piece, you could drag the screens of a switch on there, the port states, and then be able to give you an impression whether or not lines are working, and also be able to dive deeper into diagram views and out-of-the-box stuff you get with Operations Manager from this live map. So it's fully integrated, I guess. This is for the networking piece, so you could create your own live maps there. And then there's also the networking piece where, for instance, we could create a NetApp diagram and give you a storage dashboard, double-click, and I created a sample where you can see the iSCSI target, the volumes, the disks, the controller, and give you an all-up view, I guess, of the virtual NetApp that I'm using. And then you could drive it even further to do an end-to-end view where I'm including my Hyper-V hosts and the specific volumes that the VMs are using, and combine health states from both Hyper-V management pack, VMM, and also the NetApp management pack to give you an understanding of the whole fabric. So it's live maps really representing that in a better way, I guess, than we do out of the box. Now, how do you create these maps? It's actually quite easy. They have their own authoring console. So you pre-create your visualization, so like your map, the network device, etc. You say add map, and then next, select the image that we pre-created. In this case, our converged network. Select that one, hit next, and then add it as converged network. Next, and then it'll show up, and then on that surface we can actually drag and drop the health states on top of there. So this might be a Visio printout you'd normally have in your office on the wall. You'd now import it, and on the left-hand side you see all these components we can drag on top of there. And we could say, well, I want to map the blade system interconnect switch. Type HP blade system, select the class, say OK. And then on the left-hand side, you'll see all the interconnects in our environment, and we can drag them on top of that, and it should actually be good. There we go. We'll hide the image and the label, and we have a real health state on the map. You save it, and it becomes available for all the Operations Manager users. Another and then I'll switch back to the slide deck. Oh, that's Vincent. Hi, Martin, do you have a second? Well, actually, not really. We're in the middle of a session, right, guys? It's not going to work if we have a link call in between. It's quite urgent. We need to meet the SLA. We want to do capacity management. I'll quickly do that, actually. I can show you guys at the same time, I guess, how capacity management works in Operations Manager. And as you can see, I can type real quick. So I wanted to, at the end, show you a bit of capacity management. And it's a big term, right? Capacity management. It's all this stuff you need to do. But essentially, to me, a first step would be to at least have trends and forecasts. Because this management pack might be collecting like the percentage free space. But I want to know how is this going to be in the near future based on trend lines. Like we've seen the past 12 months, how will be the next 6 or 12 months? So capacity management, if you define it, it's a process to manage IT to ensure we have current and future capacity needs. There are 3 levels to do it by, is what ITIL is saying. The component capacity, so a single disk, single volume. Service capacity, which is a bit harder because all these components come together and they all need to meet capacity for the service to meet the capacity demand. And then business capacity, then you measure like volume of queues, orders. I guess they could do some capacity management on the service line here in this building. Again, but we'll look at component capacity. And if you look at the current information in Operations Manager, if you look at performance graphs, reports, essentially you're always looking back, right? You collected some performance information, you're looking at a graph, and you say, well, capacity seems fine. It's going pretty steady. Now, if you look at trending forecasting, you want to set a trend line, like a linear trend line or a deviation, standard deviation or whatever. But in this case, a linear trend line, and then say, well, it's already declining a bit. And then if you take that a step further and then start trending forecasting, you actually say, well, capacity is declining. So based on your thresholds, you could determine whether or not it will meet your future capacity. It depends on the capacity we need, right? If it's percentage free space, you might want to be alerted at 20% free space or 10% free space when it hits that threshold in the next 6 months. So you need to set thresholds, and then Operations Manager can actually do the calculation. Well, there's 70 days left before we will breach that threshold that you as an admin has set. So how do you do this in Operations Manager 2012? Well, actually, you take a management pack called the Capacity Management Pack, and it adds a new function into the dashboard framework. So in this case, if you're creating dashboards in Operations Manager, there's a new widget which you can actually use to do forecasting and trending with. So what I'll do in this demo, I'll say create new dashboard, and then say I want to have a grid layout. Give it a name. For instance, we want to do capacity trending on Hyper-V, and we'll say we want a 3-cell layout, biggest cell on top. Create, and we get this empty grid, and we can drag and drop, or we can add any widget in those cells. So what we'll do is on the top cell, we'll say add widget, and then we get this new widget called the capacity widget. We say no, it's a third-party vendor. It's an OpsLogix management pack. So you give it a name like disk capacity. You select the instance, the group. In this case, we'll just select a single Hyper-V host, PCI ST2. And then select the class we want to use, Hyper-V host. OK. And then a performance counter. The performance counter we use to start trending and forecasting. It will filter out, so we will say logical disk. We want to have the percentage free space we want to trend. Then say total free space on this Hyper-V host. And then the thresholds. So we'll say if in the next 90 days it'll breach 10% or 20% and it's descending towards the threshold, then we will set it to warning or critical, because that's the minimum number of free space we need. We'll calculate, let's say, from the beginning of the year or whatever time period you need, and we'll show 30 days in the current view. And you can actually use the navigation sliders to go back and forth. And what it should actually do in a second is show you the performance graph plus the trend line and a health state. So in this case, it's green because it's never going to hit the capacity. It's not forecasted to hit the capacity. We'll take another counter. So we'll add another widget and say the capacity widget. Give it a name, in this case, for instance, memory. So how much memory are we going to be utilizing in the next few months based on historical data? Again, PCI ST2, want to show for this Hyper-V host the capacity. Then select the counter memory. Available megabytes. Next. And then megabytes is, of course, the number of megabytes that will be free in the next period in time. So 4 gigabytes, 4,000 megabytes, coming 90 days or 6. We'll set it to warning. And again, it's descending towards the threshold. We set next. We select the time range, calculate it from January 1st. Give it a few months, and then show 30 days on screen. We'll say next, create, and then that should actually give us a demo of that we won't have enough memory in the next 90 days. There we go. It says you only have 35 days left based on the current historical data and the threshold you've set. Now, of course, there's a linear regression. You can set all these types of regression types because you might have standard deviation, etc. But it will give you at least a rough indication of the future capacity of these components. Now, if you want to do this all-up dashboard, I created one called Hyper-V capacity. It will load all the Hyper-V hosts in my environment. I just selected a group. I set the thresholds for all these three, and then at a glance you see ST2 won't meet future capacity because, as we saw, the memory will not be available. Enough won't be available in the next 35. So that's a way. Sure.
If you're running a Hyper-V cluster, can you monitor the entire cluster's memory, or are you actually stuck doing individual hosts?
So this widget actually, so the question is, if there's like a Hyper-V cluster, there's multiple memory instances, and I want to do future capacity trends on the cluster, how would that work? So we rely on the information we have, the performance counters we collect in OM. So if each cluster node collects individually its memory counters, you would individually look at those memory counters and do something dashboard-wise to make sense of both. If there's like a rule collecting them on a cluster level, we could just ping off that counter. And if not, we see people creating at least their own rules to accommodate and then use those in the dashboard carrying forward. But this is just a function to take any counter and do it like a trend line. So it depends on the management pack that will be servicing this information, I guess. Yeah, sure. So to summarize, we do have quite some comprehensive monitoring. I think the network bit is a bit stronger than on the storage side, but at least we have a story to do network monitoring, storage monitoring, and for some of these devices, really comprehensive. And then if you look at how we deliver those, you get out-of-the-box reports, out-of-the-box dashboards, but the dashboards through SharePoint and Live Maps do help a lot to give you a better visualization and also better proactive monitoring, I guess, on those. And then capacity management, if you want to do future trends, you might want to have a look at the OpsLogix management pack, which gives you the fifth dimension to Ops Manager. Besides availability, performance, security, configuration, you now have capacity, I guess. So that's what I wanted to show you today. I'll take questions now. I guess we're 5 minutes early on the session. Thank you for visiting. We do have more information on System Center if you want to subscribe to the preview bits for R2, want to look at channel 9 for the recording or the slides. And don't forget the evaluation. If there's anything I can improve for future sessions, I'd love to know. And again, thank you for attending today. Thank you.